If you want to see more topics, then check the playlist section of this channel. Also, if you want to buy my notes, then check the link in the description below. In this video, we will see an example on sinusoidal steady state analysis, nodal analysis. Question: using nodal analysis, find I/O of t in the circuit in figure. Here for this circuit, we have to find the value of this I/O by using nodal analysis. First of all, we will take this circuit from here. Now, as we can see, it is in time domain. So, we will convert this into its equivalent phasor domain. Convert time domain into phasor domain. So, here it is 8 sine 2t plus 30 degree volt. So, we have to convert this into cosine form to make it in standard format. So, it will be 8 cos 2t plus 30 degree, and here we have to add minus 90 degree to it because we are changing from sine to cosine. Now, if we simplify this, so it will be 8 cos 2t, and this is minus 60 degree volt. So, in case of phasor domain, it will be 8 at an angle minus 60 degree volt. Now, again, if we compare this, V is equal to Vm cos omega t plus phi with this standard expression. So, here we can see Vm is equal to 8, omega is equal to 2. Omega is equal to 2 radian per second. So, we got the value of omega, and phi is equal to minus 60 degree. Now, next, this 2 ohm will remain same. Then the 0.25 farad will change to 0.25 farad will change to 1 upon j into omega c. So, 1 upon j into omega value is 2 into capacitance value is 0.25. So, if we solve this, it will be 1 upon j into 2 into 0.25. It is minus 2j ohm. Then next 0.5 farad. So, 0.5 farad, this will be 1 upon j into omega c. 1 upon j into omega value is 2, capacitance value is 0.5. So, here this will be 0.5, it is minus j ohm. Then next 2 Henry. So, this 2 Henry will change to j omega L. So, j into omega value is 2 into inductance value is 2. So, it will be 4j ohm. Then next 1 Henry. So, this 1 Henry will change to j into omega L. So, j into omega value is 2 into inductance value is 1. So, 2j ohm. Then next cos 2t ampere. So, cos 2t ampere, this will change to 1 at an angle 0 degree ampere. Now we can change this value. So 8 sin 2t plus 30 degree volt will change to 8 at an angle minus 60 degree. 8 at an angle minus 60 degree volt. This 2 ohm will remain same. Then this 0.25 farad 0.25 farad will change to minus 2j ohm minus 2j minus 2j ohm. Then this small I/O will change to capital I/O. This 0.5 farad will change to minus j ohm minus j ohm. This 2 Henry will change to 4j ohm. 4j ohm. Then this 1 Henry will change to 2j ohm. 2j ohm. Then this cos 2t ampere will change to 1 at an angle 0 degree ampere. Now these values are in phasor domain. Now we can easily calculate what we have to find. We have to find the value of I/O of t by using nodal analysis. So first of all, let's assume this as the reference node or ground node with 0 voltage. This is node V1, this is node V2 and this is node V3. Now let's say all the currents towards this reference node. So first of all, let's say this is current I1, this is current I2, this is current I3. Now here we can see the value of V1 is equal to 8 at an angle minus 60 degree volt. So here we can write V1 is equal to 8 at an angle minus 60 degree volt. Now next we will apply KCL at node V2. So let's apply KCL at node V2. Apply KCL at node V2. So according to Kirchhoff's current law, summation of all the currents entering a node is equal to summation of all the currents leaving the node. Now here at this node entering current is I1. So I1 is equal to leaving current is I0 plus I2. I0 plus I2. Now I1 is V1 minus V2 divided by 2 ohm. V1 minus V2 divided by 2. V1 minus V2 divided by 2. Then next this I0 in voltage form will be V2 minus 0. V2 minus 0 divided by V2 minus 0 divided by minus j ohm plus I2. Now I2 is V2 minus V3. V2 minus V3 divided by V2 minus V3 divided by 2j ohm. 2j. Now we know the value of V1. It is this much. So let's put it here. 8 at an angle minus 60 degree. 8 at an angle minus 60 degree divided by 2 minus V2 divided by 2. We can take this on left side, so it will be minus V2 divided by minus j. Then this will be minus V2 divided by 2j and this will be plus V3 divided by 2j is equal to 0. So let's simplify this. 8 at an angle minus 60 degree. 8 at an angle minus 60 degree divided by 2. It is 2 minus 3.46. 2 minus 3.46. 2 minus 3.46 J. Then minus, we can take this V2 common. So 1 upon 2, or we can take plus V2 common. Then the remaining part will be 1 upon 2, 1 by 2. Then minus, here this will be minus 1 by 2 because we have taken this plus V2 common. So minus 1 by 2, then minus 1 by minus J minus 1 by 2J plus V3 1 upon 2J is equal to 0. Now this will be V2 in bracket minus 1 by 2 minus 1 by 2 minus 1 by minus J minus 1 upon 2 into J. So it is minus 0.5 minus 0.5 minus 0.5 J minus 0.5 minus 0.5 J. Then next plus V3 in bracket 1 upon 2 into J minus 0.5 J minus 0.5 J is equal to, now if we take this on right side, so it will be minus 2 and this will be plus 3.46 J. So let's assume this as equation number 1. Next we will apply KCL at node V3. So let's apply KCL at node V3. Apply KCL at node V3. Now according to Kirchhoff current law, summation of all the currents entering a node is equal to summation of all the currents leaving the node. Here the entering currents are 1 at an angle 0 degree, I2 and I3. 1 at an angle 0 degree plus I2 plus I3 is equal to 0. 1 at an angle 0 degree, I2 and I3. These are the three currents. Now this 1 at an angle 0 degree we can write 1 plus, now this I2 can be written as V2 minus V3 divided by 2J. V2 minus V3 divided by 2J, then plus I3. So I3 is V1 minus V3, V1 minus V3 divided by V1 minus V3 divided by 4J minus 2J. So we have to add these two to get the total impedance. So 4J minus 2J. 4J minus 2J, then it is equal to 0. So now this will be 1 plus V2 divided by 2J minus V3 divided by 2J plus V1 divided by this. So the value of V1 is 8 at an angle minus 60 degree. 8 at an angle minus 60 degree divided by 4j minus 2j. So 4j minus 2j is simply 2j minus V3 divided by 2j is equal to 0. So now this will be V2 in bracket 1 upon 2j. 1 upon 2j is minus 0.5j. Then next we can take this V3 common. So plus V3 in bracket minus 1 upon 2j minus 1 upon 2 into j minus 1 upon 2 into j, then minus 1 upon 2j. So it is only j. Then next this 1 plus this 1 plus 8 at an angle minus 60 degree divided by 2 into j. So minus 2.46 minus 2.46 minus 2j is equal to 0. Minus 2.46 minus 2j is equal to 0. So now again if we simplify this further, so it will be V2 minus 0.5 j plus V3 j is equal to 2.46 plus 2j. Now let's say this is equation number 2. Now solving equation 1 and 2. Solving equation 1 and 2. So here we can see from equation number 1 we have to put this in matrix form. So to simplify this, so let's put this in matrix form. From equation number 1 this will be this value. From equation number 2 this value. Then from equation number 1 again this term, and from equation number 2 this term. Here this will be V2 and V3. These are the two unknown, V2 and V3 is equal to, now it is equal to from equation number 1 from equation number 2 it will be this value. So now if we solve this, then we get the value of, first we will find the value of delta, and then we will find the value of delta 1 and then delta 2. So after that we will find the value of V2 and V3. So let's find the value of delta. To find the value of delta we have to take the determinant of this matrix. So let's take this matrix from here, and now we have to take the determinant of this. So let's take its determinant. So this into this minus this into this. So let's copy it from here. This into this. Minus this into this. Now let's solve this in calculator. It will be minus 0.5 minus 0.5 into j multiplied with j minus 0.5 into j, then in second bracket minus 0.5 into j. It is equal to 0.5, 0.75, 0.75 minus 0.5j. So this is the value of delta. Then next we have to find the value of delta 1. So delta 1 will be, again we have to take this determinant or this matrix, but in this matrix we have to replace the value of this first column. We have to replace this first column by this value. So this into this minus this into this. So let's take it from here. This into this minus this into this. So it is equal to delta 1 minus 2 plus 3.46 into j into j minus 2.46 plus 2 into j multiplied with minus 0.5 into j. So it is equal to minus 4.46 minus 4.46 minus 0.77 j minus 0.77 j. So this is the value of delta 1. Next we have to find the value of delta 2. So again we will take the determinant of this matrix. Now this time we have to replace column number 2. We have to replace this column with this value. So let's take these values directly from here. Now let's take its determinant. So for determinant we have to multiply this into this. So let's copy it directly. Then multiplied with 2.46 plus 2j. 2.46 plus 2j minus 0.5 j into this minus 2 plus 3.46 j. It is equal to, if we solve this in calculator, it will be minus 0.5 minus 0.5 into j, then multiplied with 2.46 plus 2 into j. Then minus 0.5 into j into minus 2 plus 3.46 into j. So this is equal to minus 1.97 minus 1.96, then minus 3.23 j. So this is the value of delta 2. Now we got delta 1 and delta 2. So we can find the value of these two unknowns. So here are the two unknowns V2 and V3. So for finding the value of V2, delta 1 divided by delta. So the value of delta 1 is, this is the value of delta 1 divided by delta. The value of delta is, this is the value of delta, it is equal to minus 4.46 minus 0.77, minus 4.46 minus 0.77 into j divided by 0.75 minus 0.5 into j. It is equal to minus 3. This value we can convert this into polar form, shift 2 3. So it is 5.02 at an angle minus 136.51 degree volt. So this is the value of V2. Now we got the value of V2. Next we have to find the value of V3. So the value of V3 will be, V3 is equal to delta 2 upon delta. So the value of delta 2 is, this is the value of delta 2, and the value of delta is, this is the value of delta. So if we solve this, then minus 1.96 minus 3.23, minus 1.96 minus 3.23 into j divided by 0.75 minus 0.5 into j. So it is equal to this value in rectangular form, in polar form this will be shift 2 3. So 4.19 at an angle minus 87.55 minus 87.55 degree volt. So this is the answer for V3. V3 is equal to this value. Now we got the value of V2 and V3, but here in this problem what we have to find? We have to find the value of IO. So here we can see in phasor domain, IO is equal to V2 minus 0 divided by minus j. IO is equal to V2 minus 0 divided by minus j. Again let's verify. V2 is equal to IO is equal to V2 minus 0 divided by minus j. Now we got the value of V2. So the value of V2 is this much. Let's take the value of V2, and now we have to divide this by minus j. So if we simplify this, we get the value of IO 5.02 at an angle minus 136.51 5.02 at an angle minus 136.51 divided by minus j. So it is equal to this much in rectangular form. In polar form, this will be shift 2, 3, 5.02 at an angle minus 46.51 degree ampere. 5.02 at an angle minus 46.51 degree ampere. This is the answer for IO in phasor domain. Now in time domain, IO is equal to, we know that small I is equal to Im cos omega t plus phi. So here the value of Im is 5.02 and the value of I is small io, and here this will be cos. Now the value of omega. The value of omega is 2 radian per second. So it will be 2t plus the value of phi is minus 46. So this will be minus 46.51 degree, minus 46.51 degree ampere. So this is the final answer for IO, and this is how we can find the value of IO by using nodal analysis. Don't forget to check out the other videos on this channel, and thanks for watching.